and we're going to start with the second module. Okay, so if you are ready and you have this open on your system, please type yes in the chat box. Okay, great. So I see a lot of you have got it open already. If you haven't, please go ahead and get this Jupyter notebook open. So now we're going to module 2, which is basically variables, basic data types, and operators. Okay. Uh, the first thing we need to understand is what is a variable. Okay. And for that, let's just go one step back, right? So we have this Python runtime environment, right? It's like this area in the memory where everything runs, right? Like you have all the Python standard library. I told you it's a batteries included programming language, right? So you have the standard library where you have all these functions and objects and so on. So that is there in one section of this runtime environment. And there's this other section where, there's this empty memory, which you can fill up with objects, right? Now in Python, everything is an object, right? Uh, so whenever we think of anything, you think of an object as this thing that sits in a memory location. Okay. Now a variable is like this name, right? It's a real like something for our convenience that points to that memory location where that object is. Okay. So every variable, right, is like a placeholder, right, for an object that is stored in Python. It's like it points to a reserved memory location. Now, we either create data within Python or we get data into Python, right? So where do we store it? In variables, right? And then once the data comes in, we do some processing, we move it here, we move it there, we save the output somewhere. How does all this happen? It's through variables, right? So let's get into a few more, variables concepts, and I'll show you how to create them, how to access them, and so on. So the first thing is rules for naming variables. Okay. Now variables can contain only alphanumeric characters and an underscore. Like there's nothing else allowed. Like A to Z, uppercase, lowercase, 0 to 9, and underscore. These are the only allowed characters. No special characters like tilde and backslash and so on. Now the next thing is variable names cannot start with a number. Okay, they have to start with either a letter or an underscore. Third thing, obviously variables cannot have a space in the name. And finally, Python obviously has a lot of objects that are already built in, right? Like for example, str refers to a string object, the object of type str. Print is the name of a function. Like you can't name your variable str or print, right? Because there's just no good reason and it'll cause a conflict within the Python runtime environment. So if you have to name it something similar, then what you want to do is probably name it str and an underscore after that, or print and an underscore after that. So basically variable name followed by underscore if you have to name it something like a reserved word, but more often than not you don't have to. But just remember that if it's a reserved word, if Python already uses that word, then you cannot use it as a variable name. Another thing to remember is that variable names are case sensitive, right? So like if you have these three different variants of the word size and we create three different variables with these names, they would be three different variables. It's not the same variable, right? And just as a good practice, make sure you give meaningful names to your variables. Like when you work in a company, like you're undergoing this Python training right now, and you're going to get a great job really soon. And it's most probably going to be at some top-notch company, right? So when you work at that company, you cannot just be writing like new str underscore one and so on, because the next person who takes your code is not going to understand anything. So give it a meaningful name, like for example, average underscore revenue underscore per underscore user, right? So that way, like people really understand what your thought process is. So here, for example, if we say 9a equal to 6, this will throw an error because the variable name is starting with a number, right? So it's not allowed by Python. Another thing is a tilde 5 equals 4. Now this is also a mistake because tilde is not allowed. Remember, we have only alphanumeric and underscore as allowed characters in a variable name. Now here are some examples of valid variable names like var, a underscore 1, x23, underscore x. All these are valid names. Okay. Now I told you in Python, right? Like everything is an object and a variable is a name that points to that object at that memory location. So every object, and by extension every variable that points to that object, has three properties, which is type, id, which is like the reference to the memory location, and a value, right? So let's, for example, if we say a equal to 5, what we're doing is we're saying there is a variable, there is an object with the value 5, right? And 5 is obviously a number, it's an integer, it's stored somewhere in memory, right? The variable with name a points to this object, it's assigned this object, right? So if we print the type of a, we print the id of a, and we print a itself, we get type, id, and value. Okay, so now it's time for you to start writing Python code. Okay, it's an exciting time. I hope we're all ready. Now, what you need to do is, this was a, if you click on this, you'll see markdown over here. Okay. But if you click on this cell, it's a code cell, right? So we can execute a code cell, right? So what it says here is create a variable called var where and assign it a value of 10. So let's type var equal to 10, right? And now I can either click on run. Let me just click on run in this particular case, right? So it ran the code and moved control to the next cell. Now, we didn't see any output because we've not written any code to generate output, right? Like how would you get an output? For example, if you type print, like we type print hello world and we got an output which was hello world, right? We have not yet typed any print statement over here. Now it says print the value, type, and reference of where. So I will say, I told you already, print is a built-in function and it's a function. So you have to open brackets, close brackets, and what you want to print has to be passed into the print function. So in our case, we want to print the value, which is where, right? We want to print the type. Now, type is another function. So what you're doing is you're passing where to the type function, and that output you're passing to the print function. Okay. So the type of where is gives you the data type of this variable, and the print function prints that output. And finally, we have the id, which is the reference of where, right? So we printed the value. I'll just type hashed. So in Python, a comment is written with hash. Okay. There are some other languages where you have like double slash and so on. In this case, it's hash. So hash type and hash id slash reference, right? So one way of running this code, another way, in addition to just clicking on the run button here, is to type control enter. So we've got our output over here, right? Now, since we had three print functions, we'll have three lines in the output. The first one is 10, which is the value. The next one is class int, which basically means the type of where is integer. The class type of where is int. And finally, we have ID of where, which is what is the address of that memory location, which is this big number over here. Okay, so remember, every object in memory has a type, an ID, and a value, and you can print those using the variable name, ID of variable name, and type of variable name. Okay, so we finished this first exercise for naming variables and checking the properties of these objects. So let's move on to the next thing. Okay, now this is just like 2 minutes of concepts, right? So Python is a dynamically typed and strongly typed language, right? Let me explain what that means. The first thing you need to understand is when I say dynamically typed and strongly typed, I don't mean like typing on the keyboard. I mean type in terms of data type, variable type, object type. Okay. When we say dynamically typed, what we mean is we don't explicitly say int x or float x or string x. We don't declare that variable type. We just say x equal to 5 or x equal to hello world or x equal to 7.5, right? And Python dynamically infers or understands the type from what we have written. So it is called dynamic typing. Okay. So on one side, Python understands the type dynamically. We don't need to explicitly say anything, right? The second thing is strong typing, right? Now, strong typing means that certain types of objects, or rather, certain types of operations are reserved only for certain types of objects. Like you can add an integer to an integer, right? But you cannot add a string to an integer, right? Because that makes no sense. And if you do that, Python will throw an error, right? Also, you cannot convert an incompatible type to another type. Like you cannot convert a list to an integer, right? It makes no sense. So, or you cannot divide a string by 2. It makes no sense. So, wherever you have, so Python is very clear that I can convert from certain types to certain other types. Python is also very clear that certain types of operations are not allowed on certain types of data, right? And if you do those things, Python will throw an error. So that's what strong typing means, right? Uh, Weak typing means the object that is in memory, right, will now start becoming interpreted in a different way. Like, for example, if there was an integer at some memory location, which was, let's say, something like this, right? Then with weak typing, with certain types of code, suddenly that integers start getting interpreted like a string or a list. And maybe it's allowed in some languages, but it's not allowed in Python, right? So it's not that strong typing is better than weak typing. It just means that that's a design choice in the language. Okay, and you just need to respect that design choice. Uh, a very important concept you need to understand is immutability. Okay, immutability means once an object is created, so the contents of that object are in some memory location, right? Those contents cannot be changed. Okay, that's what immutable means. It cannot be changed. So in Python, there are only three things that are mutable, that is, can be changed. That is a list, a dictionary, and a set. Okay. Outside of that, like your integers, floats, strings, everything else, Boolean, everything else is immutable. It means that once I create that object, I cannot change its value, right? So if I type a equals 4, right? And then I type a equals 5.6, and then I type a equals xyz. It's not like Python is saying in that same memory location, I am creating these new different values. No, no, no. The value 4 exists somewhere in memory. The value 5.6 exists somewhere else in memory. So what used to point to 4 will now point to 5.6, which is a different location. And then xyz is somewhere else. So it points from here to here to here. And in effect, it's pointing to new object. It's not changing the value of an existing object, okay? Because those objects are immutable. So we've understood dynamic typing, we've understood strong typing, and we've understood immutability. Okay, so let's do these exercises now, right? So let's create a variable called mixed and assign it a value 7.8. So I'm going to say mixed equals 7.8, and I request you to please follow along. You will feel so much better when you start writing code. You get that confidence. So just follow along with me. Now I type mixed equals 7.8 and I say run. So now there is a new variable created called mixed, which has a value 7.8. So it says print out the type and value of mixed. So I'm going to say print type of mixed. And on the next line, I'm going to say print value of mixed, which is just the name. And I'm going to say run, right? So now it gives me class float. So that is the type. The class type of mixed is float. And 7.8 is the value. Let me do one other thing. Let me just type the ID of mixed also, the reference, okay? Because I think this will be important later. So now I have this memory location also here, memory address. So assign a new value to mixed. Let's assign it to a string, okay? Just remember, I just told you string is also immutable, right? So when I say assign a new value, all I'm saying is I've created a new object which is a string you use to point to a float. Now point to that string. Okay, I'm not like changing the value at that original memory location. So I'm saying mixed equals this is a string, right? So this is a new value for mixed, and I'm going to say run. So I'm going to now print out the new type ID and value. So print type of mixed, print value of mixed, and print ID of mixed, right? So let me run it. And now you'll see the difference here, right? Initially mixed was of class float. Now it's class string. It had a value of 7.8 before, or rather it pointed to an object which had a value of 7.8. Now it points to an object that has the value. This is a string. And this was the location in memory before, and this is a location in memory now. The very fact that you see these are two different addresses tells you that these are two different objects. Okay, so it's not like you magically rewrote the contents of memory. It basically means a new object got created, and like where the mixed variable points to changed. Okay, so the question here is, how do the above results demonstrate immutability in dynamic typing? So think about it for a moment. Like I created this variable here, I printed out some type, then I assigned a new value to this variable, and then I printed out this stuff again. So how do these actions and the outputs of these actions represent or demonstrate immutability and dynamic typing? So what does dynamic typing mean? It means that I did not specifically mention a type and Python dynamically figured out the type, right? So here I have not said float mixed equals 7.8. I just said mixed equals 7.8. So that represents dynamic typing. And I had initially shown you the memory location of mixed, that is the which object did mixed point to, and then I changed the value and now it points to a new memory location. So basically the old memory location value did not change. It still exists and it's somewhere else, right? So that shows you immutability. It's like the value did not change in the original location. So I'm going to write here, we did not specify a type explicitly, that is dynamic typing, and the original value did not change. the variable just points to a new object. So that is immutability. Okay. So let's try another thing now, right? Like let's try to print a string which is concatenated with an integer. So, or I try to add a string to an integer. Let's, instead of saying concatenated, let me just say add. And um, I'll teach you a shortcut here. So if you press control and forward slash, you either comment or uncomment a line, right? Like I'll press control and forward slash. So I've uncommented it. Now if I press it again, I comment it. So it's like a toggle. Okay. So control forward slash. And let me just run this code. And you can see that it throws a type error, right? So basically saying can only concatenate string to string and not an integer to string, right? And how, so does this result demonstrate strong typing? Yes, because I cannot perform incompatible operations in string and int. So the above result demonstrates strong typing. Okay, are we clear up until this point? We've understood what a variable is and like how objects look in memory. We've seen that every object has an ID, type, and a value, right? We've also seen the rules to name variables. We've seen that Python is dynamically typed, strongly typed, and immutability exists for everything other than dictionary, list, and set. Now, are we clear up until this point? If we are, just type yes in the chat box. And to whoever asked Binay, yes, once the video is, once the live stream is completed, the video gets added to a playlist and you can access it anytime. Okay, so then let's continue with this. I think we're covering good ground today, so let's continue and keep up the pace, right? If you want to get a drink of water in between, please go ahead. Uh, you can take 30 seconds to do that. And the next thing I'll teach you about is these different basic data types, and we'll have some fun exercises like how to, perform certain calculations, how to, compare things and so on. It's fun. So just have a drink of water and let's continue. Okay, so let's get started with data types. Okay, the first data type we're going to look at is none, right? And as the name suggests, it basically is used to denote a missing or empty value. Like the none data type kind of shows the lack of a value, right? And it's something called a singleton class, which basically means that, like for example, if I had integer, right? I could have created one integer with the value of 5, one integer with the value of 6, and basically an infinite number of integers, right? But I can only create one instance of none, right? And I can assign it to variable A, variable B, variable C, and any number of variables. But the fact is they all point to that one instance. So that's why it's called a singleton. Okay. So all I need to do is say x equals none, print x and print type of x, right? And I'll show you what I just meant by this. So let's say create a null variable called, not null variable, variable. So null underscore var equals none. That's what we would say. So print null underscore var, that's the value. Print type of null underscore var, that's the type. And print ID of null underscore where, right? Uh, and let's run this. So the value is obviously none, and it's not the string none. It's the type of object of none type, right? So none type is a type, and none is the value of that type, and this is the location at which it is, right? Now let's say I create a second variable called null where underscore 2 equals none. Now let me print out the address of null where 2. So that is null underscore where underscore 2, right? And if I run this, you'll see that both these IDs have the same value, which basically means that these two variables point to the same object, right? Which means that there is only one object with the value none, and all these different variables point to it. So it's a singleton. So I hope you've understood the none data type. Now the next thing we look at is integer, right? An integer is like the most common thing that we all use. So what exactly is an integer? It's a number that can be either positive or negative. It's a whole number, right? Without a decimal part. So it basically takes discrete values. And when I say discrete, what do I mean? I mean like it jumps from 1 to 2, 2 to 3, 3 to 4. There's nothing like 1.2, 1.3 or so on. There's discrete jumps, and that's what an integer is. Now, what are the typical use cases for an integer variable? You see things like how many students are there in a classroom? Like you can have a value of 45, you can have a value of 50, but you can't have 46.5, right? That makes no sense. Similarly, how many pairs of shoes did I sell? Or do I sell on an average per day, right? I can say 100 pairs or 150 pairs, but there's like 125.5. I don't sell 125.5 pairs, right? I either sell 125 or 126. Similarly, what is the age of an employee in years, right? So if I leave out the months and the days part, somebody can either be 36 or 37, right? So these are examples of integers. Sorry, just give me a minute. Yeah. So I would say x equal to 5, print x, and print type of x, right? So this basically tells me that this is a variable that points to an integer with value 5. And the type of that is class int. So the exercise is create a variable called num shoes sold daily and assign it a value of 85. What is its type? Num shoes sold daily equals 85. Print type of num shoes. And so I've typed a little bit. If I press tab, then it'll look in the namespace and it'll autocomplete. And if there are multiple options, it'll show you those options, right? So it's just a like autocomplete. So if I run, then I've assigned it a value of 85, and because of dynamic typing, Python has inferred that the type of num shoes sold daily is integer. Okay, so remember, integer is either negative or positive whole numbers without the decimal part. Okay, now moving on to the next numeric thing, which is float. Now float is a number with the decimal part, right? And it can be either positive or negative. And theoretically, it can take an infinite number of values because I could have 1.23, 1.233, 1.23333, whatever. So these are called continuous values, right? Integer was discrete values. Float is continuous values. Now, what kind of things would you track which would have a type of float, right? It could be average revenue per users. Like take the example of Airtel, right? They must be having a few 100 million subscribers, and they earn some set amount, a few $1 billion per quarter. So if you divide those $1 billion by those hundreds of millions of users, then you have the average revenue per user, which would typically be some decimal thing, right? So that's a float. Similarly, you'd have somebody's height in meters. Like my height is 1.93 meters, right? That's 193 centimeters. So the 1.93 is a float. Somebody else could be 1.65 and so on. So here you would say x equals 8.9 or whatever the value is. You'd print x and the type of x, right? So let's create a variable called height in meters and assign it a value of 1.93. What is the type? So let's say height in meters equals 1.9, sorry, 1.93. Print type height, and instead of writing the whole thing, I'll just press tab and it completes, right? So let me run this code, and you can see the type of height in meters is class float. What does this class thing mean, right? So class is like the definition, right? Uh, think of it like when you make a building, the first you make a blueprint, that is the design on paper, and then some civil engineer or some construction company comes and they build the house, which is like the real world avatar of something which was on paper, right? So the class in Python is basically the equivalent of that blueprint. It's like the definition, right? And the object, which is in our case 1.93, it's the instance of that blueprint, right? Like in this case, that instance has a value of 1.93. In some other case, it could be 1.85 and so on. So that's basically what this class float means. Now moving on to the next type, which is Boolean, right? So a Boolean is used for logical true or false. Like for example, uh, is the person is the patient female, or has the candidate graduated from college, or is the customer's age greater than 50 or 40, right? So the answer to this question is yes or no, true or false. And for such data, the Boolean data type is best because it can take only one of two values. So I can say x equals true with capital T and then print x. I can say x equals false, and if I do the type of x, it will show class bool. So let's create a variable called female patient and assign it a value of true. Just remember, okay, capital T for true, capital F for false. So female patient equals true, print female patient and print type of female patient. And let me say run. It says the value is true and the type is class bool, which is Boolean. Okay, so just a quick update. We've seen none type, which is a singleton, indicates the lack of a value or a missing value. We've seen integer, which is like whole numbers, positive or negative. We've seen float, which is continuous values with numeric values with the decimal place. And we've seen Boolean, which is true or false, yes or no, 0 or 1, kind of, right? So let's now move on to operators, right? Now, what is an operator? Like an operator basically performs some calculation, right, on numeric variables. More often than not, numeric variables, but there are some exceptions. Like, for example, this plus operator works on strings, where I say hello plus world would type hello world, right? Uh, the the multiplication operator also works on strings, where if I say hello into 3 will give me hello hello hello. But outside of this, outside of strings and lists, mostly these operators are used to work on numeric data types, which is either int or float, right? So so let me take you through the list of operators and what they mean, and then we can practice this using exercises. Let me just confirm that there are no comments. Okay, so somebody just asked me to explain dynamic typing. I'll show you what it means right now. Okay, uh, so we have plus, minus, into, and divide, which is our standard addition, subtraction, multiplication, division. Then we have the percentage symbol, which means modulo, right? So modulo is like the remainder after division. So if you say 5 modulo 3, the answer to that is 2, because 3 into 1 is 3, and what is left over when you subtract from 5 is 2. So the remainder is 2, and that's what the modulo operation would give you. Double star is basically exponent, power of, right? And then double forward slash is floor division. So if modulo gives you the remainder, then floor division gives you the quotient. Like using that same 5 divided by 3 uh, example. So 5 modulo 3 is 2, because 2 is the remainder, and 5 floor division 3 is 1, because the quotient is 1. 3 into 1 plus 2, right? Okay. Now for the student who asked dynamics, Saurav, you asked about dynamic typing, right? So dynamic typing basically means that I do not explicitly say int, float, bool, or whatever when I declare a variable. I only say x equal to 5, x equal to 7.8, and so on. And Python automatically figures out that x is of type integer or x is of type float. So that's what dynamic typing means. Okay, so let's now do these exercises for arithmetic operators. So it says create two variables a and b. Assign a value of 4 and b a value of 5. And then do all these different operations with a and b, right? So let's say a equal to 4, sorry, 4, b equal to 5. And now instead of writing that many different print statements, I can perform all these calculations by just comma separating them, right? So first I'll do a plus b, comma, a minus b, then a into b, then a divided by b, then and instead of a by b, I'll do b divided by a, right? Then I'll do b mod a, I'll do b to the power of a, I'll do b floor divided by a, right? I think I've covered all these different operations. So let me say run. Okay, so a plus b, that's 5 plus 4 is 9. A minus b, which is 4 minus 5, is minus 1. A into b is 20. B divided by a, that's 5 divided by 4, is 1.25. B mod a, which is a is 4, b is 5. So the remainder after you divide b by a is 1. That's 4 into 1 plus 1. Now b power a is 5 power 4, which is 5 into 5 into 5 into 5, which is 625, right? And b long division a, which is, I told you, the quotient, right? So if you divide 5 long division, not long division, sorry, floor division by 4, then the answer is 1, because 4 into 1 is the max multiple of 4 when you divide 5, and then 1 is the remainder, right? So quotient is 1, remainder is 1. The remainder you saw here, and the quotient you're seeing here. Has everyone understood what these different operators mean? You can just type yes in the chat box. Okay, good. Let's keep it going. So we've already seen the result of all these different operations on variables, right? Arithmetic operators. Now let's do the next exercises. Create a variable called Q2 days to calculate the number of days in the second quarter of the year, which is April, May, June. What is the value and what is the type of Q2 days? So let's say Q2 underscore days equals how many days in April? That's 30. plus how many days in May? 31 plus 30 in June, right? So 30 plus 31 plus 30. So let's print Q2 underscore days, comma, type of Q2 underscore days. And let me run using the shortcut or the keyboard shortcut, which is Control Enter. If I press Alt Enter, it will execute the current cell and create a new cell underneath it, right? So I don't want to create a new cell, so I'll just use Control Enter. Now, Q2 days is 91, which is correct, and the type is integer, which is also correct. Now, the next one is create a variable called num seconds to calculate the number of seconds in a non-leap year. What is the value and what is the type, right? So what is a non-leap year? Just remember one thing. Uh, the point of programming is never to get the answer right in the first step. It's to always have a logical thought process uh, towards solving a problem, right? So the first thing, rather than just writing code, let's figure out what is a non-leap year. Non-leap year is a year which has 365 days, right? And how do you calculate number of seconds? So you have 365 days into 24 hours per day into 60 minutes per hour into 60 seconds per minute. Okay, so num seconds equals 365. Actually, let me say non-leap year days equals 365, right? And I'll show you another way to do this. Num hours per day equals 24. Num mins per hour equals 60. Num seconds per min equals 60, right? So this num seconds non-leap year is just the product of these four variables I created. So non-leap year days into num hours per day into num minutes per hour into num seconds per minute, right? So either I can write these values directly over here, or I can write them in the form of variables. And the only thing is, just imagine if you were passing on this code to somebody else, some other member of your team, this approach would make more sense. Now I'll just print the value and type of num seconds non-leap year and time. Right, so let me just say run. So it gives you this big value, which is the number of seconds in a non-leap year, and the type of that value is integer. So basically number of days into hours per day into minutes per hour into seconds per minute, right? So think about it, logical thought process. Now let's look at the next one. Q3 days, number of days in the third quarter. Find the difference between Q3 days and Q2 days. So just remember one thing with this Jupyter environment, once you have run a cell, right? Like I have, like for example, we already run this cell. Then this Q2 days variable is available even in the other cells. So whatever you've run before is available after that. So Q3 days equals July, August, September. So July has 31, August has 31, September has 30, right? So find the difference between Q3 and Q2 days. So I'll just say print Q3 underscore days minus Q2 underscore days. So instead of assigning it to a different variable, I'll just print the output directly and I'll say run. The difference is 1, right? So to see why the difference is 1, let me just print 3 things. Q3 days, comma Q2 days, comma Q3 days minus Q2 days. So I'm printing 3 things, okay? So you can see one has the value 92, 1 has the value 91, and so 92 minus 91 is 1. Okay, so let's move on to the next thing now. A company had 50,000 customers in Jan, right? They lost 2875 customers in Feb. So how many customers are remaining? Cust Jan equals 50,000. Cust Feb equals Cust Jan minus 2875, right? They had 50,000 in Jan and they lost 2875. So minus 2875. How many customers are remaining? So print Cust, let's go Feb, right? Now, if the remaining customers spend an average of $20 a month, how much monthly revenue can the company expect, right? So the revenue would be Cust Feb into $20 per user. That would be the monthly revenue. So let me run this. So there'd be 47,125 customers remaining, and at $20 per customer, this would be the monthly revenue. So I printed number of customers and the revenue. Okay. A company spends 1,20,000 rupees a month on catering services, right? 40 employees, 25 working days per month, 3 meals per day. What is the average amount spent per employee per meal? And what is the data type? So let's say budget equals 1,20,000, right? Now, number of meals per month. Instead of that, I'll just say num meals per month equals. Actually, let's again follow the logical approach here. Num employees equals 40. Num working days equals 25. Num meals per working day equals 3, right? So how many meals per month? It's the number of employees into the number of working days into number of meals per working day. So let's print. No, so we've got number of meals per month, right? And we've got a budget. So all we need to do is how much are we spending per employee per meal, right? And the answer is to divide 120 by this. So print budget divided by total number of meals per month. 40. So we're spending 40 rupees per meal per employee. And how did we arrive at that number? We got the total number of meals per month by multiplying employees into working days into meals per day and divided budget by that number. So again, like we could have done it just using the numbers directly, but this approach indicates the logic behind the thinking. Okay, so let's go to the next one. A company orders 100 boxes of sweets to be evenly divided between 24 employees. So each employee gets the same number of sweets, and the remaining boxes are donated to charity, whatever is left over. So how many boxes of sweets does each employee get, and how many are donated? So num employees equals 24. Num boxes equals 100. So num so boxes per employee equals number of boxes divided by number of employees. Boxes donated equals number of boxes modulo. Sorry, in the first case, it's not just division, it's floor division, right? Because each employee gets the same number of boxes. So when I say there are 24 employees and there are 100 boxes, the number of boxes each employee gets is 100 floor division 24. And the number of boxes that are donated to charity are basically what's remaining. So 100 mod 24. That's number of boxes modulo num employees, right? So let's print boxes per employee and boxes donated. So there were 4 boxes per employee, which is because 24 into 4 is 96 and 100 minus 96 is 4. So there were 4 boxes donated. So the 100 floor division 24 gave us 4, which is per employee. And the 100 minus 96 gave us the 4 donated to charity, right? Now, let's move on to the last thing under arithmetic operators. So a working professional decided to invest 6 lakhs in a fixed deposit at 7% per year for 3 years. So this is like our 9th and 10th standard compound interest problem. Calculate the total sum he received at the end of 3 years. What is the type of the variable? So if you remember the compound interest formula, it's principal into 1 plus r by 100 to the power of t, which t is the number of years, right? So total sum, so let's go the structured thinking way. Principal equals 6 lakhs. Rate equals 7% means 0.07. Time equals 3, right? So total sum equals principal into 1 plus rate to the power of time. And this, I would just put this whole thing in brackets, right? Because this calculation is done first and that is multiplied by principal. So principal into 1 plus 0.07 to the power of 3. So print total sum and type of total sum. Let's say run. So this is the amount, 7,35,025, and it's of type float, right? So we use the exponent operator to calculate compound interest. Now this is a very small section, and I'm just going to like close out today's session. I think it's been a little intense. So let's cover comparison and relational operators and then close out for today, and then we can continue tomorrow onwards. Okay. Now, in the previous section, we saw arithmetic operators, right? So we had variables and then we had operators and then we had the output of those expressions. That whole thing was called an expression and we have an output, right? Now, comparison operators are used in different kinds of expressions, okay? So the output of these expressions is basically like a true or false. Now, for example, if I were to ask you, is A greater than B or not, right? So the answer to that is obviously true or false. It cannot be anything else. So this is what comparison operators do, right? They compare one variable to another and give us an output, which is a Boolean, that is a logical true or false. They're used to perform comparisons. It's like running a test, checking if a condition is true or false. So you have these different operators, right? So you have greater than or equal to, less than or equal to. Then you have the equality operator and the not equal to operator. So when you say A operator B, you're basically testing a condition. And if the condition is true, then it returns true. If the condition is not true, it returns false. So you'll understand it better with some exercises, okay? Now, company X sold 2,000 toys at 450 per toy. Company Y sold 3,500 toys at 300 per toy. Now we have to check if the following statement is true or false. Company X has lower revenue from toys than company Y. So we'll say X revenue equals 2,000 toys into 450 per toy. Y revenue equals 3,500 toys into 300 per toy, right? And what is our condition? Print X has lower revenue than Y. So X less than Y, right? And I don't want to just print that. I also want to print the values of X revenue, Y revenue, and X revenue less than Y revenue, right? So the first thing will give you an answer, which is the revenue of X. The second thing will give you the revenue of Y. And the third thing is an expression which checks if this condition is true. So let's run it. So the first thing is this value, which is 9 lakhs, right? The next thing is Y revenue, which is 10 lakh 50,000. And the condition is X revenue less than Y revenue. That's 9 lakhs is less than 10 lakh 50,000, which is true. So this is the answer. This is the output of that expression, that this expression is true. So let's move on to the next example. A school is raising money for charity. So there are 9th grade students and 10th grade students, right? The 9th grade students, there are 60 of them and they give an average of 150 each. The 10th grade has 90 students who give an average of 100 each. Now let's test these statements, right? One after the other. So first is, remember we can't start a variable name with a number, right? So we can't say 9th grade or 10th grade. So we have to say grade 9 total equals 60 students into 150 each. 60 into 150. Grade 10 total equals 90 students into 100 each. 90 into 100, right? So the first thing, is this statement true or false? 10th graders totally gave at least as much as 9th graders, if not more. What does at least as much as, if not more mean? It means greater than or equal to, right? So the condition is print. So let's actually just print these two values first. Grade 9 total, grade 10 total, right? And now we want to print that 10th graders gave at least as much as 9th graders, which is grade 10 total greater than equal to grade 9 total, right? Let's test it. So the 10th graders totally gave 9,000, the 9th graders totally gave 9,000, and this condition evaluates to true because 9,000 is greater than or equal to 9,000. If it was just greater than, then it would have been false, but since it's greater than equal to, it is true, right? And now the next statement. 10th graders gave exactly as much as 9th graders. So we have to use the equal to operator. So print grade 10 total equal to grade 9 total, right? And this is also true because both gave 9,000. Okay, so we've seen the less than, we've seen greater than equal to, and we've seen the equality operator. Now let's go on to the third exercise here. Is this statement true or false? the fourth power of 2 is not equal to the second power of 4. So print, what is the fourth power of 2? It's 2 to the power exponent double star 2 to the power 4, right? That's the left side. And the operator is not equal to. And the right side is second power of 4, which is 4 power 2. So basically the statement is saying 2 power 4 not equal to 4 power 2. And let's run it. It's false, right? Because 2 power 4 is equal to 4 power 2. 2 power 4 is 16, 4 power 2 is 16. So this condition evaluates to false. So we've seen arithmetic operators that perform operations mostly on numeric variables. Now we've seen comparison operators that compare different variables and give us a Boolean as an output, right? So I think we're good for now. I'll complete the rest of this tomorrow because there's still some ways to go. I don't think we'll be able to finish the whole thing today. Uh, yeah, so we're like 2/3 of the way through this second module, and I just want to know if you have any doubts. Okay, somebody has asked what is the difference between division and floor division, right? So let me just I'll just create an additional cell here to explain that. Insert cell below, right? So I have a cell here. It's a code cell, right? Now let me just explain it first, then I'll show you the answer, right? Like let's say numerator equals 10, right? Denominator equals 3. Now if I divide the numerator by the denominator, actually speaking, 10 divided by 3, what do I get, right? I get 3.33333, whatever, right? But let's say I don't want that point part, right? I just want what is the quotient, what is the remainder, right? So let's do it this way. Print, what is the quotient if I divide 10 by 3? So for that I use floor division, right? And let me run it. So the quotient is 3, right? That's what floor division is used for. Now, what is the remainder if I divide 10 by 3? That's what I get using modulo. 1, right? So basically what I'm saying is, so we have this equation, right? Basically numerator equals denominator into quotient plus remainder, right? Like that's how we think of it, right? Like 10 is equal to 3 into 3 plus 1. So this part is the floor division part. This is the modulo part. So is that clear? Okay, so I think that that brings us to the end of today's session, right? We've covered, I'm going to close this. We've covered the entire module 1, which was our introduction to Python. We saw what Python was all about. We saw how to install it. We saw what dev environments to use. And then we went to module 2, right? We understood the different types of variables, like what is a variable in the first place, the type, ID, and the value. We saw the different types of variables, which are int, none, uh, Boolean, and float. And the reason I didn't include string is that we will cover string as a part of collections, right? As much as string is a basic data type, it's also a collection. So I'll cover it under collections. Then we saw the different arithmetic operators and including the plus, minus, into, divide, as well as the modulo, exponent, and floor division. We also saw comparison relational operators, uh, where we compare one quantity with another, and the output is a Boolean, which is either true or false. What's the difference between normal division and floor division, right? So normal division would give you the entire decimal part. Floor division will just give you the integer part. So one gives you 3.33333, which is normal division, and just floor division will just give you the integer part. That's the difference. Okay, so I hope you had a good session. Uh, if you have any doubts or if you have any feedback, I'd love to hear from you. Uh, our email ID is mentioned in the website. It's missionai.org@gmail.com. I'd love to hear from you. And I hope you found this useful. And I'm looking forward to seeing you again tomorrow. So have a good night. And when you get a chance, just practice what we've learned, go through the exercises yourself, and come up to speed. Finish up comparison operators, and then tomorrow we'll start with logical operators and then some basic built-in functions. After which we look at Python collections like string, list, dictionary, and so on. Okay, so have a good evening. Take care and great job. You've followed all the way through, so keep it up. See you.